AI engineering, I mean, it's got to be one of the most in-demand careers on the entire planet right now. But here's the thing. In a field where today's hot new tool is tomorrow's legacy code, how do you actually build a career that lasts? It's not about chasing trends, it's about building a solid strategy to adapt faster than the industry itself. So let's break down how to do it. This quote right here really highlights an uncomfortable truth. The ground is just constantly shifting under our feet. The very tools we're building to automate tasks, well, they're now starting to automate parts of our jobs. And this isn't some distant threat. It's a reality that raises a pretty critical question for every single person in this field. So, how do you stay ahead? It's not about fighting the future, it's about building a career that's resilient to it. We're going to break down 3 core strategies to do just that: mastering timeless foundations, thinking like a systems architect, and, maybe most importantly, leaning into your unique human advantages. Okay, first, let's really unpack this central conflict that's facing every AI engineer today. It's a concept I like to call the automation paradox, and believe me, it's at the very core of why future-proofing is so absolutely essential. So here's the paradox. Your skills are in incredibly high demand, right? Yet the tools we use are becoming, well, frighteningly competent. AutoML platforms, code generation models, they can now handle complex tasks that were, not that long ago, exclusively human. This isn't something that's coming. It's happening right now. But hey, this is not a reason to panic. It's a reason to level up. So, how do you start leveling up? Well, the first strategy is actually pretty counterintuitive in a field that moves this fast. You need to go deeper, not wider. It's all about mastering the timeless foundations that, let's be honest, so many others are tempted to skip. Every single new AI trend, it doesn't matter if it's multimodal transformers or generative agents, is built on these same core principles. Think about it. Linear algebra, optimization, probability, this stuff is the bedrock. A lot of engineers race to learn the newest framework, but they completely miss the math behind it. And that's a shortcut with a very, very short expiration date. And this really highlights a crucial distinction. Tools like PyTorch and TensorFlow, they're incredibly powerful, but they're just temporary solutions built on permanent principles. The lasting value isn't in knowing a specific library's API. It's in understanding what's actually happening under the hood. Can you derive a loss function from scratch? Can you figure out why a model has stopped learning? That's the skill that endures. And this all leads to a really interesting career paradox. The more you focus on deep theory, the more practical and adaptable you actually become. So when some new paradigm emerges, whether that's quantum-inspired AI or neurosymbolic reasoning, the engineers who know the underlying math can pivot immediately. Everyone else, they're stuck on page 1 of the new API documentation. Now let's look at the next evolution of the AI engineer. This is all about shifting your focus from just building isolated models to architecting entire intelligent systems, systems that go way, way beyond the model itself. This is where this idea of meta-engineering comes in. You see, you don't fight automation. You build the systems that manage and extend it. Your job literally shifts from being the person doing the task to the person designing the automated system, making sure it all works safely, efficiently, and ethically. You're orchestrating the machines, not just coding one of them. And here's why that is just so important. In many cases, the model itself is no longer the hardest part of the job. Not even close. The real challenge is all the infrastructure that surrounds it. Getting data in, optimizing training across a bunch of GPUs, and then serving that model reliably with clear observability. That's what defines production-level AI today. And this means you've got to master the tools of the trade for infrastructure. We're talking about cloud-native MLOps, containerization with tools like Docker and Kubernetes, and all the pipeline frameworks that stitch everything together. It also means knowing how to evaluate and integrate really powerful open-source components into your systems. This is what separates a practitioner from a true systems architect. Finally, let's talk about the skills that are uniquely human and, because of that, are the hardest to automate. This right here is your ultimate competitive edge. Specialization alone just won't be enough in the future. Your value absolutely skyrockets when you can become a translator, a bridge between the technical world and the rest of the business. If you can explain a complex system in terms of business value or design principles or ethical risks, you become indispensable. Just think about what this looks like in practice.
It's being able to explain model fairness metrics to a CEO in one meeting and then turning around and discussing data privacy implications with the legal team in the next. It's all about building that cross-disciplinary fluency, which lets you see solutions that others, who are stuck in their silos, just can't. And this human-centric advantage, it extends all the way to ethics and governance. AI's future isn't just about code. It's being shaped by policy, like the EU AI Act. Understanding how to embed fairness, accountability, and explainability into your models, that's not just about compliance anymore. It's about building trust. And trust is quickly becoming the ultimate competitive edge. So, let's bring this all together. Let's put this into a clear playbook for your career. This quote really just says it all. The goal isn't to become an expert in today's hot new framework. The goal is to build a foundation so solid that you're ready for whatever comes next, even if it hasn't even been invented yet. The people who are really going to thrive will be those who can blend those strong fundamentals with system-level thinking and that cross-disciplinary intuition. Tools and APIs, they have a really short shelf life, but the cultivated ability to adapt, to learn, and to evolve, that is the ultimate future-proof skill. And that leaves us with one final thought. The technology we build is constantly getting smarter, faster, and more capable. The real question is, are you evolving right alongside it?